our conversion from logarithmic form to exponential form and back as a means to solve logarithms. So here we do want an actual answer. We want to figure out what this logarithm is going to give us. And remember, logarithms are the answers to those are exponents. In order to help us do this, we have an important concept here where we can just take a logarithm and add an x to it, an equals x, and then it's going to be in logarithmic form, and then you can actually rewrite this to exponential form to actually find the value of x. So here we are trying to figure out what is the answer, and we're going to do that by rewriting. So the first step that we're going to do here is set this equal to x. The next step is to take this logarithmic form and change it to exponential form. So again, this starts with the base of 6. It raises it to the x power. So we've got 6 to the x equals 36. Now that we have it in this form, what we're thinking about is how many times do we multiply 6 together to get 36? This we can use logic and just try something. So here, let's try 6 times 6. What does that give us? That is 36. So how many 6's do we have? We have 2. So this is going to be x equals 2. So we're actually figuring out the value of the answer. All right, let's do the same thing here. So again, we're going to set this equal to x. We're going to convert it from logarithmic form to exponential form. 10 to the x equals 1,000. And then we're going to think to ourselves, how many times do we multiply 10 together to get 1,000? So 10 times 10 is 100. Times 10 is 1,000. So how many 10s do we have? 1, 2, 3. So the answer here is 3. And think about, if I put 10 to the third in the calculator, you should get 1,000 out. Let's look at this problem. So set this equal to x. Then convert to exponential form. 6 to the x equals 216. So let's just try this. 6 times 6 is 36. Ooh, that's not 216. So let's multiply by 6 again. And that gives us 216. So we have 1, 2, 3 6's. So this is going to be 3. So 6 to the third would give us 216. And our last one of these, set this equal to x. Convert to exponential. 7 to the x equals 1. And this one might be a little bit harder to think about. So how many times do you multiply 7 together to get 1? This one's kind of a unique mathematical rule. And if you remember, we might have talked about this before. You might have heard this before. But anything to a certain power equals 1. So what power is that? So the key here is that you have to know that if you raise any number to the 0 power, that's going to equal 1. So how many times do you multiply 7 together to get 1? No times. 0 times. So my answer is 0. And you could certainly put 7 to the 0 power into your calculator, and I can assure you, you will get the answer of 1. Okay? So that's just basic logarithmic forms that we can kind of figure out just by multiplying that base out. Let's look at some other examples. Another property of logarithms is if we have bases that are the same, the answer is just the exponent. And I want to show you why. We use this rule for exponentials. So if this base for this exponent or exponential expression is the same as this base, then it's only logical that the exponents have to be the same too, for that to be equal to each other. So you could set the exponents equal to each other. Let me do what we've been doing on the previous 4 problems. Let's do that with this one. And I want you to think of 6 to the 8th as all the same expression. Those are kind of attached together. So we're going to set it equal to x. And we're going to convert to exponential form. So starting with our base here on the logarithm, 6 to the x power equals this whole expression 6 to the 8th. So now if we apply this new rule we have that if the bases are the same, the exponents are equal, then here I can say that these exponents are equal, and my answer is just 8. So here I get x is 8. I'm going to do it one more time here. Let's set it equal to x, convert to exponential, 2 to the x equals 2 to the 5th. Set the exponents equal to get the answer. So x is 5. Now I'm showing you the logic and the mathematics behind why this works, but what I would like for you to be able to do is not have to go through all of that. I would like for you to be able to look at a logarithmic expression and be able to understand that if I have an exponential expression here, and that base is the same as the base on the logarithm, my answer is just the exponent. Okay, so here what I want you to see is if this base and this base is the same, the 2 is your answer. I don't want you to have to go through all this. This is just giving you the understanding of why this works. I want you to be able to use this understanding to go straight to, okay, these bases are the same, therefore the answer is just the exponent. And it's because this will work out every single time. So if we do that over here, we just need to understand that e is also just a number. So I've got 2 numbers that bases are the same. My exponent is 3, so 3 is my answer. So on the next step, on the next lesson, next part, we're going to talk about radicals and how that comes into play with our logarithms.